2.4 Determine the instant at which M and N meet. Specify whether M will meet N before or after reaching D. So when they meet, this means that the x of M equal to x of N. That's why now we need to write an equation in order to find the instant at which they meet. So in 2.4, we have to write x of M equals x of N, right? X of M is found to be in the previous part equal to t squared. So t squared is equal to, and xn is already given, minus 0.8 t squared plus 30t. So in this case, we obtain an equation of one unknown, which is t. Move them to the other side, we get t squared, change their sign for sure, plus 0.8 t squared minus 30t equal to 0. 1.8 t squared minus 30t equal to 0. We take t in common. Let's say it's 6t in common. Okay, so we'll be left with 0.3t. We're factorizing now. 0.3t minus 5 equal to 0. So we say that either t is equal to 0, which is the initial instant from which they started, from the initial position. So this is not the required time. We want to find out when will they meet later on. So solving the other factor, 0.3t minus 5 equal to 0. So 0.3t equals to 5. T equal, divide both sides by 0.3, sorry. So what do we obtain in this case? Using your calculator, you can find the answer. 5 over 0.3 is 16.66. Now specify whether M meet or when will M reach D first. Then we have to compare the time at which M reaches D. We already calculated the time at which M reaches D. So here it is in part 1.2. It reaches D at t equal 14.83 seconds. And we said that, or we calculated the time at which they meet. This means that it reaches D before they meet. That's why here the answer is specify whether M will meet N before or after reaching D. M will meet N after reaching D. Why is that? Because the time at which it reaches D is 14.83. The time at which it reaches D is 14.83 seconds, which is less than the time at which they meet. It is 16.66. So after or before, we say that M will meet N after reaching t. Now calculate the speed of car N at the meeting instant. Calculating the speed of the car, we have to refer to the speed-time equation of the car N. The speed-time equation of the car N was found in part 2.2. Refer to it. It is V equal minus 1.6 t plus 30. So 2.4 V equal 1.6 V of N is equal to minus 1.6 t plus 30. Okay? So they want the speed when at the meeting point. The meeting point is at t equal 16.66. So you substitute minus 1.6 times 16.66 plus 30 is equal to 1.6 times 16.66 is minus 26.65 0.65 plus 30. This is equal to 3.34 meters per second. Determine the time interval now. This was 22.5, not 2.4. Now 2.6. Determine the time interval during which the speed of N is higher than that of M. Now we need to find the speed. This means that we have to work with the speed time equations. Vn is minus 1.6 t plus 30, while Vm, we go back to the part about Vm, we found that the expression of the speed time equation for the M is Vm equal to t. So now the question is, speed of N is higher. We have to substitute in 2.6. We have to write an inequality, which is that Vn is greater than Vm, and substitute the expressions. Vn is minus 1.6 t plus 30 greater than, we said that Vm is equal to 2t. Right? So we have that minus 1.6 t. We get all the unknown on one side and all the known on the other side. So it's minus 2t greater than, moving the 30 to the other side, it becomes minus 30. So this is minus 3.6 t greater than minus 30. Because we have a negative coefficient of t, we multiply that equality by negative and we have to change it to invert it. So it becomes 3.6 t less than 30, dividing or multiplying both sides by negative 1. Now divide both sides by a positive value, which is 3.6. 3.6 and 3.6 cancels. We get that t is less than, and we have calculated 30 divided by 3.6 is 8.33 seconds. So this is the range of time when t is between the initial instant and less than 8.33 seconds and moves at a higher speed than m. Part B